Okay, this is the second part of lesson 3.5. We're talking about the properties of logarithms. We're going to talk about some additional properties of logarithms. We're going to talk about the product rule, the quotient rule, and the power rule. These three here. And these are for when x is greater than 0, y is greater than 0. These are all positive numbers. The base is positive, and it's not equal to 1 because then we'd have a 0 exponent, right? And it's any real number r. Okay? So what it's saying on the product rule, if we have, if our argument is two things multiplied by each other, so this is our argument, it's two things multiplied by each other, then that can be written as the sum of two logarithms, log of a, log of x, and log of y, right? That's the two, those are the two products can be written as a sum. The quotient rule is quotient is division, right? So the quotient rule says that if our argument is one number divided by another, we can write that as a subtraction of two logarithms, the difference between two logs, log of x minus the log of y. And the power rule says that if our argument is some exponential function, x to the r, right? And then we're not going to have the same basis like we had on the last function, but x to the r, then we can put that exponent out in front of a log and it's the same thing. So we multiply that exponent times log a to the x, and those two are equivalent functions. And they give some examples down here on the bottom. 8 times x is the same as log of 8 times log of x. Remember, this is, we don't see the number down there, that's base 10. They put the base 9 here, but it doesn't matter. It doesn't matter what the base is. It still works the same way no matter what the base. So division problem, 15 minus 7, log of 9, 15 minus 7. The power rule, we have its square root of 8 can be written as to the 1/2 power, so we can take that 1/2 and put it in front of the log of 5 to the 8. Okay, so we jump from that right to this nasty looking problem here, and assume all variables are positive to rewrite the expression. Okay, so we've got log of base b, and this is it's got this kind of square root looking thing, but it's got the n here, so that's the nth root of x to the third, y to the fifth, divided by z to the m. Okay, so we got a lot of exponents, we got a lot of letters here. It's kind of an alphabet soup. Okay, so the first thing we want to do is try to change this root thing to look like an exponent. So to do that, we would put parens around it and rewrite this as log of b, and all in parens, to the 1 over n power. Right? Because that's if we had a 3 here, we put 1/3. If we had a 4 here, it'd be the 4th root, or 2. We normally don't write the 2, so it would be 1/2. Okay, so now we can use that 1 over n using our power rule. We can write that in front of all that mess. So we write that like that. We get rid of the parens, and we have 1 over n times the log of b, and 3x to the third, y to the fifth over zm. Now we can use our product rule and our quotient rule to work on this a little further. Remember, the product rule says two things multiplied by each other is the sum. The quotient rule, divided by each other, is the difference. So we can write these as sums and differences. So the sums would be like this. It would be x to the third, log of x to the third, plus log of x to the y equals, or minus log of b to the z to the n. That's using the quotient rule here, changing the multiplying to addition, the division to subtraction. Okay, but now we've got these logs again. These are all to powers, right? 5, 3, 5, and m. So now we can use the power rule again to put those 3's, the 5's, and the m's in front of our logs, and all this is still in parens to the 1/n power. Or multiply by 1/n, I mean. So you put the 3, you put the 5, you put the m in front. Okay, so this would be fine. If you do this on a test or on a quiz, that would be fine. I would accept that answer. That would be perfectly fine. The book goes one step further. They get rid of the parens and they write it all out like this. They just multiply 1n times everything, and it's just those numbers in front divided by n. Okay, so not as bad as it looks when you first saw it, but if you're not real good with these power rules and stuff here, the power quotient and that, if you're not real familiar with those, when you first try these problems, it can be a little challenging. So refer back to those, write those down if you need to, because those you're going to be using those on the problems for homework tonight. Okay, now we're going to go back the other way. We've got all this log all the way written out, and we want to go back and write it as a single logarithm. So these are kind of like little, they're not so much logarithm, you're not solving for anything, you're just changing what it looks like. Okay, so a lot of little algebra, a lot of following the different rules here. So we realize that these are multiplied by different things here. So we're going to probably apply the power rule there. The plus is going to be multiplying. The minus is going to be dividing. Okay, so we got to remember those rules when we do in logs about the power and the product and the quotient rule. Okay, so they first applied the quotient rule. They put that 1/2 m to the 1/2, and they had to put that in parens, 2 times n to the 2/3, and we didn't do anything with the last log b because it wasn't, it was okay the way it was. We didn't have any powers in front of that. Okay, so then the next step was to undo the sum. The sum would have been multiplying and the subtraction would have been dividing. Okay, so we wrote everything like it was. So this would be all this log times 1/2 times 2n. Now we've gotten rid of taken the log stuff out of each of these and made them a multiplication problem. This back to multiplication and this back being a fraction underneath. Okay, so now we can do now we're looking for ways to simplify it a little more. Okay, so with these 1/2 and the 2/3 powers, one thing we can do here is we can distribute the 2/3 powers and recognize that this 1/2, the m and are on top and bottom, right? And 1/2, if you have something to the 1/2 over 2, you would just be 2 minus 1/2 on the bottom, and that's where they got that 2/3. And just distribute the 2/3 to get 2, and the n was 2/3, and that's to the first power minus 1, and so that's how they got the 1/2 left with 1/2 on top. So that's just the exponent rules that it may or may not be that familiar with, but they used them here to simplify the top and the bottom m and n. So they just had one, they didn't have m and n's on the top and the bottom, they just had n on the top, m's on the bottom. Okay, so now we have to recognize that this is, each one of these exponents is divided by 2, so we can do the whole thing times 1/2. And 2 to the 3rd times 1/2, m to the 3rd on the bottom, n. And remember, this 1/2 is just another way of saying the square root, so they wrote that as a square root. 2 to the 3rd is 8, so it gets back to a single logarithm, looks like that. Okay, change of base rule. Change of base rule is just what it says here. If we have, and it's used when we didn't have as good at calculators as we have now, and you only had log tables, we had to look things up in tables. It's a little antiquated right now. I'm going to show you how to use it on your calculator to figure these out without going through so much stuff here, but it's good to know where it came from and why it works. So it says that if you have a log of a base a to the x. You can rewrite it with any base you want, right? These base b can be anything we want. Log x divided by log of whatever base we wanted to the x divided by log of b times a. Log of b of a. The arguments a and x there. So this becomes the argument on the top. This base becomes the argument on the bottom. Okay, and this base can be anything we want. And usually you choose base, usually we go, the natural log, log 10, or you can go, the common log, or you can go the natural log, the base e, because that's mostly what's on your calculator. And this little proof down here is pretty good. It goes back to the definitions of what things are. So they did a substitution here. They said this x was a to the y. Okay, so they put that in here, and this is the same thing. A to the y and x are the same because we just said they were the same. Okay, then we use the power rule here. Then we solve for y, divided both sides by log b of a, and you got this answer here, right? That y equals that. And since y equaled the log of a to the 10th, it didn't matter. That's the proof of it. So we got back to looking like this. We could do that with any base, and usually use base 10 or base e to do those problems. Okay. Evaluate each expression, round to decimal places. Okay, so if you have a scientific calculator that does not have this function I'm going to show you, you have to use that product rule to do that. You have to take the argument goes on top, and usually use base 10 divided by the base, the log of whatever base you want, usually base 10 on the bottom. So they do that with base 10. So they take the 17 divided by log 17 divided by log 5, and they get the answer. They do log of 0.1 divided by log of 2, and they get the answer. You get the same answers when they do it with the natural logs, right? It doesn't matter which base you use. And these are the two bases that are built into the calculators. So it really doesn't matter which base you use. Okay, I'm going to show you a way on the graphing calculator, so at least all the graphing calculators with the latest operating system, how that works. Okay, so if we had, what was the problem there? It was log 5 to 17. Okay, so you hit the math button here, the math button, and you get this menu. And I put this up big so you can see it easily on the screen. And hit the up arrow to go to the bottom of that math key, and then you get this one thing that's called log base. Put that in, and you get this on your screen. So log of base 5, and then I'm going to put it to 17, enter, same thing they got, right? Same thing they got here, same thing we got there. So it's an easy way to do it. It looks just like the problem you have from the book. And I'll do one more. What was the other one they had? Log 2.1. So hit the math key, go down to the bottom of that list, hit log base, and it was 2 and 0.1. Enter. Of course, it's going to be negative because our argument is less than 1. And that's the same answer they got. Yeah, same answer they got. Okay, except a few more decimal places. Okay, so that's an easy way to use your calculator to do that change of base rule, right? So if you see this change of base rule, I expect you to use your calculator to solve it. Either this way, like they show here, if your calculator doesn't have that change of base function built into it, or if it does, use this to do that. Okay, so that's the end of the lesson. Fill out the form at the bottom. I'll see you tomorrow in class. Write your questions.